Hey everyone! In today's lesson, we'll be taking a look at how to convert between the symmetric, functional, and general forms for the equation of a straight line. So in your notebook, please put down today's subtitle, Convert Between the Forms of a Line's Equation. First, we'll take a look at how to convert any other form into functional form, which is the format y equals ax plus b. The key thing to remember about functional form is that y has to be isolated on its own side of the equal sign, and everything else has to be shoved over to the other side of the equal sign. As long as your algebra skills are strong enough to accomplish this, you'll be fine. Let's try the following example. Take a moment to copy this down. First, we'll begin by leaving the y variable on one side of the equal sign, and we'll move everything else to the other side of the equal sign. In this case, we're going to have to move over the 2x and the negative 7. Or if you wanted the y variable on the right hand side, you can simply just move over the negative 4y. The choice is yours. For now, I'll move the 2x and the negative 7 over to the other side. Next, I'll finish isolating the variable y by dividing everything by negative 4. This will give me a final rule of the line in functional form of 1 over 2x minus 7 over 4. Next, let's try the following example. This example is written in symmetric form. But again, if you remember what the format for the functional form looks like, then as long as your algebra skills are up for it, it shouldn't be a problem. We need to get y isolated and everything else on the other side of the equal sign. So first, my decision is to move over the x over negative 3. Leaving the y over 2 on its own already. And therefore the negative x over 3 will become positive x over 3. And I still have that plus 1. Next, to continue isolating the y, since it has a denominator of 2, I'm going to multiply everything by positive 2. Thereby giving me a final rule of the line in functional form of 2 over 3x plus 2. Next, let's take a look at converting to the general form for the rule of a straight line. For the format of a general form, it helps if you remember the following. Everything is shoved over on one side of the equal sign, while the empty side is set to 0. Let's try with the following example. This rule is written in functional form, y equals half x minus 5 over 3. First, I will begin by shoving everything over to one side of the equal sign. In this case, you have your choice. You can choose to move the y variable to the right-hand side, or you can choose to move the half x minus 5 over 3 to the left-hand side. My personal choice would be to move the y variable to the right-hand side, because that would only give you one object to move versus moving two objects. So for me, my next line will look like the following. Half x minus y minus 5 over 3. So as you can see, we're halfway there. We have everything move over on one side, and the empty side is equal to 0. But there's one more condition for general form. It cannot have any fractions. We have a denominator of 2 and 3 still hanging around. Best way to get rid of them is to multiply the entire equation by the lowest common multiple of all visible denominators, in this case 2 and 3. And I believe that the lowest common multiple between 2 and 3 is 6. So my next line would look something like this. I'm going to show that I'm multiplying everything by 6. And when you distribute the 6 to every monomial, you will get the following. 3x minus 6y minus 10. And there it is. We have a proper general form. Next, let's try converting this to general form. This is a rule of a line written in symmetric form. Again, you have a choice here. You can choose to move the 1 over to the left-hand side of the equal sign, or you can choose to move the negative x over 2 and the negative y over 3 over to the right-hand side. My personal choice would be to move the 1 over to the left-hand side, because that only gives you one object to move over. So my next line of work will look something like this. X over negative 2 plus y over negative 3 subtract 1 is equal to 0. Now again, to get rid of the denominators, the best way to do it is to multiply everything by the lowest common multiple of all visible denominators, in this case 2 and 3. So again, you have a choice. You can choose to multiply everything by a positive 6 or a negative 6. Both are acceptable. My personal choice would be multiplying everything by a positive 6. So my next line of work will look something like this. At the same time, I'm going to choose to combine the plus and a negative on the 3 into a negative overall. And to finish up, when you distribute the 6, you'll end up with this final answer. And you can see that is proper general form. Everything is shoved over to one side, the empty side is 0, and there are no fractions. For someone who chose to multiply everything by a negative 6, they will end up with the following rule. Both are acceptable. And finally, let's take a look at converting into symmetric form. Symmetric form is really easy as long as you remember the following. The key components are the x-intercept and the y-intercept. There has to be a plus, and empty side is equal to 1. So no matter which form you're in, as long as you determine the x and the y-intercepts, you'll be fine. To illustrate this process, let's try this example. This rule is written in general form. I'll begin by determining the x-intercept, which is the value of x when you set y to 0. So, using your algebra skills and setting y to 0, if no problems happened, I got an x-intercept of 5 over 2 or 2.5. Next, I will determine the y-intercept, which is the value of y when you set x to 0. So, again, using your algebra skills and setting x to 0, if I didn't make any mistakes, I got a y-intercept of 5 over 3. Now that I have both the intercepts, my rule is very easy in symmetric form. It's x over the x-intercept, so 5 over 2. Yes, I know it looks funny, but you're allowed to have fractions in the denominator. Has to be a plus. Y over the y-intercept. And empty side is always equal to 1. And there it is, ladies and gentlemen, how we convert from every form to every other form of a straight line.